Good morning, good morning, good morning. Hope all is well. Everyone's doing all right. Haven't seen you guys in a week or so. So hope you had a great week and all that. Um, Hope you were able to check out what I sent to you guys before we do that. So we're looking at our classes on Tuesday and Thursday. So I just went ahead and decided as far as our final exam. Our exam will be on Thursday, August 5th. I'll write this down for you. Let's go here. So our final exam, we're looking at August 5th. And it's going to be during class time. So what's this class? 11 to 1. So you get 2 hours to do the test. It shouldn't take 2 hours. Well, I'll say it like this. I didn't create 2 hours worth of problems for you to do, but you can use the 2 hours, as you desire. And if you want to have a note sheet, feel free to have notes out. What else? So I believe for this class, I'll look at it and I'll tell you for sure on next class. I believe the way I set up your final exam for this class is that chapter 4 is your final exam because it incorporates or pulls from all the other chapters. So I said it was just good enough to make chapter 4 your final exam, and we'll do it that way. So you'll log on to Zoom, you'll enable your camera. So during class time, yeah, do you have this up? Just making sure I had the right thing up. During class time, I don't make you enable your camera, but on that day you would have to enable the camera. So if you have to get your hair done and all that stuff like that, get a proper background, whatever it is you have to do, that day you do have to make sure that your camera is enabled. And then what's going to happen is you're going to see your final exam as an option in your assignments. But when you click on it, it's going to ask for a password. So you wouldn't get the password until the day of your final exam, after you show your ID. And I'm going to send you an email with all those final exam details and all the stuff like that. So try to send that out today sometime. Send you out that email, give you all the details. Everything that I'm saying will be in that email. So make sure once you log on, show your ID. Like I said, enable your camera, show your ID, get your password, that you stay logged on. Because I've had people in the past to get everything, get the password, then they log out of Zoom. So so then I'm looking at you like, what was the purpose of us doing what we just did there? So make sure that you stay logged in on Zoom. Now you can go to another window, but what you don't want to do is hit the X button to close out because you're supposed to be proctored. That's supposed to be proctored. Now, I will give the opportunity. This class ends at 1, so around 1:30 on the same day, a makeup opportunity will pop up. So you won't see that till around 1:30 of that same day. So now the highest you can get on that makeup is 75%, because really your final exam is supposed to be proctored. You know what I mean? So giving you this option, it's just me throwing you the opportunity to get the grade that you would like out of the class. Now, a 75 on the final exam will not stop you from getting the A, but it depends on what you've done up to that point. So I have to put certain things in here like that to at least create this, illusion that, there's penalty. Now, like I said, it'd be harder to get the A, but it won't stop you from getting the A. But if you scored less than a C, then this one you will take advantage of the makeup opportunity. Questions on anything?
So I got two quick questions real quick. So firstly, for the makeup exam, is that going to be proctored as well?
No. You just do it on your own. It's like I say, when at around 1:30, it'll pop up in my math lab. It will not be password protected or anything. So really, the last time I actually see you will be during the proctored final exam, and then from there you have from Thursday to Sunday. Because don't forget, 8 Sunday midnight will be the last time you can submit anything in my math lab. So you will have from Thursday to Sunday to take advantage of the makeup opportunity.
So the makeup is going to be the average of the two scores you get.
Oh no, the makeup will be what In other words, if you were to, if you do the makeup, do better on the makeup than you did the regular, the proctor test, then I'm taking the makeup. Now, if you score anything higher than a 75, there's no purpose in you taking the makeup.
Right.
So when it comes to the makeup, I'm not going to take 25 off of whatever you score. It's just that the highest thing you can get is a 75. So if you score a 90 on the makeup, it will be a 75. But if you score a 70 on the makeup, it'll just be that 70. You see what I mean? So the highest you can get on the makeup is a 75.
Okay.
Mhm.
Yeah, that makes sense. And then, so for the final exam, it's everything on chapter 4, right?
Yes, it'll be chapter 4.
All right. Thank you.
Yep, not a problem. And like I said, let me confirm that. I believe that's what I did for this class. Where in chapter 4 was pretty much your final exam because, like I said, it pulled from all the other chapters. I'll confirm that and let you guys know for sure next class.
Okay.
Yep. Anything else? Anybody else about the final exam? Anybody trying anything get stuck? Anybody have any questions or anything? Any problems? Chapter 1, 2, or 3? Anything? Anybody? So right now we have 2 days this week, 2 days next week. So just throwing you a heads up on the calendar. Today's the 20th, 22nd, 27, 29. We're looking at 8283. I mean, not 82, 27, 29, 83. Yeah, so I'm looking at 85. So final exam day is here. So we have 5 days to get through 4-1 through 4, but 4-4, and then do whatever review we're going to do. So that's what we're looking at. Should be able to do 4-1 through 4-4 within the next 2 days. Maybe we'll pull it out or drag it out to 27. That's fine. But then you'll have the 29th and the 3rd to ask whatever questions you want to ask on anything. You know, from chapter 1 all the way to chapter 4, whatever you want to ask, you can be able to ask that. So, all right. So before we get started, is everybody good? All right. So let's look at 4-1 exponential functions. All right, so the exponential function with base b is written in this way. You got f of x is equal to b with our, notice x is not b times x, it's b to the x power. So our variable is actually going to be the exponent now. So there's b to the x power. And then notice it says b is a positive constant other than 1, because 1 to any power, of course, is just going to be itself. So it's going to be b. B has to be something other than 1. And then x is any real number as your variable. So let's say if we had to graph f of x is equal to 2 to the x power. I'll scroll up. And a lot of times in my math lab, they'll give you what they want you to plug in. A lot of times they'll go from 3 to -3 as integers. But if not, those are what I'll be using. So let's say if we go from 3 to -3, like I said, as our integers. So we plug it in 3. Once again, this is not 2 times 3, this is 2 to the 3rd power. So anything you put you know, up here is going to multiply 2 times itself that many times. So notice the progression of what we have here. 2 to the third power is 8. 2 to the second power is 4. Then we have 2 to the first power is 2. Now, anything to the 0 power is 1. All right. Then don't forget how negatives affect our number. It drops our number down into the denominator. So that's 1 over 2, and then 1 over 2 squared is 1 over 4, and then 1 over 2 cubed is 1 over 8. So that's the effect of having our variables exponents. Let me put that back in the chart. All right, so any questions before we look at the graph? All right, anybody still copying? All right, so here's the graph. So if you're talking about when x is 3, y is 8, that's this point right here. Then 2, 4 is here. 1, 2 is here. And then 0, 1. Yep, it's right there. And then you're talking about negative 1, 1/2. Then negative 2, 1/4. Negative 3, 1/8. And then it will continue to get smaller and smaller and continue to get closer and closer to 0. So notice the jump. This will continue to get higher and higher very quickly. That's what it means to grow exponentially, because that exponential growth will jump quickly. So, you know, that's, 3, 8. When you put, 4 in there, it jumps to 16, and then 32, 64, 128, and so on. All right, any problems before we go to the next thing? All right, so next thing they mentioned is your natural base E. And E to the first power. So E, when you see it from this point forward, cannot use it as your variable. Normally we don't use it as a variable because of the natural base E. E to the first power has value. That's 2.71882818 and so on. It is irrational. But if you add an exponent, or not an exponent, if you put a number other than 1 there, then it will have that effect. So E squared, E to the third power, and so on. So the last thing that they use or talk about in this section is your compound interest. In banking, whenever you have money either invested in an account that has a certain type of interest, or if you have a loan that has interest applied, when it compounds or when the interest is applied, you have these 2 different types. So you have for n compounded periods per year, this is the formula. A is equal to P times 1 plus R over N raised to the N times T power. So this is an exponent. N times T is an exponent. And we got what P, R, and N is down a little lower, just in case, you haven't seen this in a while. We'll get to that in a second. And then for continuous compounding, you have P times E to the RT power. So R times T is an exponent. And of course, that E is the natural base that we just finished mentioning. All right. So this is what those letters represent. P is your principal, which is your deposit or your loan. R is going to be your rate. Don't forget to convert that to a decimal before you go to plug that in and calculate with it. T is your time. Your time is going to be in years for all the problems that we use. All right. N is the number of compounding periods per year, and then A is your future value. All right. So now when it comes to number of compounding periods per year, they're going to give you a keyword. Oftentimes they give you keywords versus the actual number of times, just bank lingo, I guess. So when you see these keywords, that'll let you know what N is supposed to be. So annually means it only happens 1 time per year. So N is equal to 1. Semi-annually, twice a year. N is equal to 2. Monthly, 12 times a year. N is equal to 12. Quarterly, N is equal to 4. Weekly, 52 weeks in a year. So, and then daily, we're going to do 360 instead of 365. That's Banker's rule. So Banker's rules say we'll do 360 instead of 365. You know, see one that says 360 is just an easier calculation. In 365, and then I saw another one that says that, you know, as far as reasoning and rationale, to use 360 instead of 365. Another one said that there are 5 major holidays in a year. So whichever one they decide to use 360. All right, scrolling up. All right, so let's use these formulas. So you decide to invest $8,000 for 6 years and have a choice between 2 accounts. The first pays 7% per year, compounded monthly. The second pays 6.85% per year, compounded continuously, which is the better investment. So once again, if you have a number, when you go back, just want to emphasize this. When you have a compound number of compounding periods, it's going to be the first formula. If it's continuously compounding, it's going to be the second formula. So that's different than daily. Continuous compounding is a different formula altogether. So I'll give you a chance to write that formula down. All right. So whenever dealing with word problems, I always like to write down the given information first. And then we'll go into calculating whatever we can off of the given information. So the first account is 7% per year. Well, for both of them, let's start there. For both of them, we know that we have $8,000 and 6 years. So that doesn't change, you know. So notice we have P is $8,000. The rate is 7% for the first account. Like I said, time is 6 years. And it says we're going to compound monthly. And so that's why N is 12. Now, you can put all of that in the calculator this way. You know, use this to raise it. It's called a hat, or sometimes people call it a caret. To raise 12 times 6, to your exponent. But we have P, which is 8,000 times 1 plus R over N, 0.07 over 12, raised to the 12 times 6 power, N times T, excuse me. And that gives us this formula right here. And our formula with this result, 12,160.84 cents. All right, so if you don't have a calculator that can set it up just like this using parentheses and the caret and everything like that, then you have to do things in pieces. You know, follow order of operations. You know, remember you want to do what's in the parentheses first. So you would do this 0.07 divided by 12, add it to 1, and you get that solid number. You can go ahead and multiply these together. 12 times 6 to give you 72. So whatever this result is, you raise it to the 72nd power and then multiply it times 8,000. So you just have to perform order of operations, but you still should get the same result. If you have any questions or problems with your calculator, you always can feel free to, you know, bring it to class one day, you know, through Zoom, and then I'll help you set up, you know, how to function with the calculator. So may have to stay after class one day or something like that. All right. Any problems with the first account? All right, second account, having green. Remember our percentage, not percentage, our principal is the same. We got 8,000 that we want to invest. Our time, 6 years, still the same amount of time. And then our rate changes. And then compounded continuously changes. So we have to use that other formula. And that's what we have right here. 8,000 times E to the 0.0685 times 6 power. So in a scientific calculator, you should have both of these, you know, the E function, the natural base, I should say, and the ability to raise it to that power. All right, and this should be the result. All right, any questions? All right, so comparing the two, we see at the top one is the better investment. Make a little more money. Now, after 6 years, though, because one is being compounded continuously, the second one will probably start to make more money after a certain amount of time, just because it's continuously being compounded versus the other one being monthly compounded. But what got us here is that this is at a 6.85%. It's at a lower rate versus the other one being at 7%. So after 6 years, the first one would be a better investment. But not so, you know, you don't know how much it would be, you know, after 8 years, after 9 years, 10 years. But I know that continuous compounding should increase the amount at a faster rate. All right. Any problem before we go to the next thing? All right. So that's all that 4.1 focuses on. Any questions before we look at 4.2? All right. So 4.2, we're going to introduce logarithmic functions. See the relationship between logarithmic and exponential. So here, excuse me, for when x is positive and b is positive and b is not equal to 1, right? That's what all that says right there. We're talking about being greater than 0. We're talking about being positive. Notice we have y is equal to log base b of x. So your base of your log is going to be b, and it's applied to x. And notice we said that this is equivalent to b to the y power equal to x. So this is considered being in logarithmic form or being a logarithmic function. And this is considered being an exponential form. All right. So let's look at how we will go or transpose between the two. Notice that no matter which form that you use, your base is the same. So b is the base of our log, and also b is the base of our exponent. All right. So now what's going to be different is what is b next to in that relationship. So here, b is next to x, y is on the other side of the equal sign. But here, b is next to y as the exponent, and the x is on the other side of the equal sign. So you're just switching the relationship of what's next to what. And that's how I always look at it. I start off with my base is the same. And then whatever's next to my base in the logarithmic form will not be next to my base in the exponential form. All right, so can I scroll up? Make sure everybody copy that before we actually implement it. All right, so I've already written it out, but I can go ahead and erase it just so we can walk through it. So A, B, and C. The first one we have 2 equal to log base 5 of x, and we want to convert that to the exponential form. So once again, notice how I started with 5. 5 is my base. 5 is going to be the base regardless. So if I want to write an exponential form, notice that x is next to the 5 in my log form. So when I go to write it in my exponential form, that means 2 needs to be my exponent, and x needs to be on the other side of my equation. All right. Same thing with the next one. Start off with your base. My base is 3 of my log. So my base of my exponent is going to be 3 as well. Y is going to be my exponent. 7 will be on the other side of the equation. So once again, whatever's next to 3 in this relationship should not be next to 3 in my other relationship. And then the last one, my base is A. So I start there. 64 is next to A in the logarithmic relationship, so it should be on the other side of the equation. In my exponential relationship, making 3 my exponent. All right, questions before we go to the other thing, the reversal of the process. All right, so now we're reversing the process. Same thought still, but we're going from log or exponential to log. But it's the same thought process. In the first, we have 12 squared equal to x. So the base of my log will be 12. 2 is next to 12 here. So 2 should be on the other side of my equation in my log form. And that means we're going to have log base 12 of x equal to 2. All right. Next one, b cubed equal to 8. That means log base b of 8 equal to 3. And then here we have e to the y power equal to 9. So it's log base e of 9 equal to y. All right. Any problems with either one of those before we go to the next thing? It should be all right. All right. So looking at general properties of our logs. So any log, no matter what the base is, so log base beta means we talk about generally. No matter what the base is, if you apply the log to 1, it's going to be equal to 0. Then if you have log base b of b, that's going to be equal to 1. Log base b of b to the x power will be equal to x. So notice that 2 and 3 are very similar, wherein what they're saying is if you have log base b of b, no matter whatever the exponent is, that's what will be left. So, when you look at this right here, log base b of b will cancel out, leaving you with just the exponent. Well, the same thing happens in 2 because the exponent is 1. So log base b of b cancels out and it leaves you with 1 as the exponent. So remember that relationship, log base b of b. Whatever those numbers are the same, the only thing that will be left is the exponent. And then here in 4, if you have b, very similar to 2 and 3, if you have b and you raise that to log base b of x, so in other words, this whole thing is your exponent, then this will cancel out, leaving you with just x. All right. So in the purple, we just have examples of that with numbers. So log base 5 of 1 is 0. Log base 7 of 7 is 1. Log base 4 of 4 to the 5th power is just 5, because once again, the whole piece cancels out, leaving you with the exponent. And then 8 raised to the log base 8 of 9 is 9. That cancels out, leaving you with just the 9. All right, questions. All right, let's scroll up. All right, so the next thing, your common log. Common log is log base 10. So they're going to assume that if you don't see anything there, they're going to assume that you know that there's a 10 there. So right here, if you see log of x, log of 9, log of 10, and there's no base, they assume you know that there's a 10 there. That's the only one you can assume. That's the only thing you can assume as far as not seeing any number there at all. There's a 10 there. So log base 10 of x is log of x. That is your common log. There's always a 10 there. Anything else has to be recognized. So in other words, if I want to do log base 2 of x, you have to see the 2. All right. Any other number has to be there. So here are the properties using the common log. Log of 1. Once again, any log applied to 1 is 0. Then log of 10 is going to be 1 because remember your base is 10. So log of 10, log base 10 of 10 is 1. Then log of 10 to the x power is x. And then 10 raised to the log of x is just going to be x. All of those same principles from before, properties from before, we're applying here, just that our base is 10. All right, very good. Now we have the natural log. We talked about that natural base before in the previous section of E. So whenever we have our base, excuse me, as e, that's the natural log, and that will be represented as ln of x. So whenever you see ln, they assume you know that's the natural log and that the base is e. Okay, so those are the two in your calculator, in your scientific calculator, that will always be there, the common log and the natural log. Common log, base 10, that's when you don't see a base there at all. And then the natural log, which is ln of x, which is your base e. And so properties specifically assigned to your natural log when you have e involved as your base. So natural log of 1 is 0, natural log of e is 1, natural log of e to the x is x, and then e to the natural log of x is x. All right. Any problem before we look to apply this? All right, let me erase some of this stuff so we can walk through it. All right, so we're looking to simplify some expressions. So the first one, log of 100. So we know our base is 10. So if we can rewrite 100 in terms of 10, that will help us in our simplification process. So we can rewrite this as log of 10 squared, because 100 is 10 squared. Now that we're rewriting 100 in terms of 10, log and the 10 will cancel out, leaving us with just 2. And that leans on, that property. All right. Next one, we have 10 raised to the log of 33. Remember, if you don't see anything, they assume you know that the base is 10. So this cancels, leaving us with just 33. All right, any problem with either one of those two? All right, so the next one, our base is e. Talk about natural log, our base is always e for natural log. So if I can rewrite that 1 over e to the 6th power, in terms of e, that will help. So I'll rewrite that as e to the -6. So you don't forget your exponent rules. So to bring that e up to the numerator, I can rewrite that power as a negative exponent. And now that I've done that, that allows this part to cancel and leave me with just -6 as my answer. All right, so in the fourth one, e to the natural log of 75, that cancels, leaving me with just 75. So any problems with those 4 before we go to the next one? All right, so here we have log base 3 of log base 7 of 7. So just like with anything else, order of operations, you do what's in the parentheses first. So log base 7 of 7 is 1. All right, going back to your properties, one of those 4 properties. Now you have log of 1, and any log, no matter what the base is, applied to 1 is going to be 0. All right, any questions? All right. So the next one we have log base 5 of log base 2 of 32. So the first thing you want to do is write or simplify what's in the parentheses, like I mentioned before. So we have log base 2 of 32. So now it'll be hard for me to do anything going further unless I can rewrite that 32 in terms of 2. And that's what I do right here. I write log base 2 of 2 to the 5th power. It's all dependent upon what my base is. My base is 2. So if I can rewrite 32 in terms of 2, that's what will help me. All right, so log base 2 of 32, change the 32 to 2 to the 5th power. So that will now reduce to just 5. Remember, log base 2 of 2 will cancel, leaving you with just 5. And now we have log base 5 of 5, which is 1. So you're just taking those properties, taking your time with those properties, and simplifying the expression that you have. All right. Any questions on 4142? Now 4142 short. Let me see how much we have in 43. 43 is actually short as well. We want to do this today. I guess we can pause right here. There's 2 sections, and then you have, you know, the other work that you most definitely want to make sure you're caught up on, up to chapter 3, so we don't have to rush it. So next class we'll get into 4.3 and probably knock out 4.4 as well. Any questions on anything before we look to close out today? Everybody okay? Okay, some questions, especially on this stuff, may not even come up till you actually try the stuff out. But yeah, make sure you're good on chapters 1, 2, and 3 as well. Try the stuff out. See if you have any questions. Notice that, you know, just like today, we had room to answer questions. So that room will still be there moving forward. Since it was posted in my math lab, then it'll be due August 8th. Somebody asked when was chapter 3 test due. Everything posted in my math lab is due August 8th. August 8th. Yep. Just make sure, don't forget, scratch work for your test. You shoot that to me. A lot of people are doing it. So if you've been doing it, you're fine. You have been getting your, you know, confirmation emails from me, but if you haven't been doing it, make sure you do that. And go from there. So if you guys are good, I'm good. I'll see you on next class and we'll get into 4344. All right, you guys have a good one.
Thank you, Professor. Have a good day.
Thank you. Thanks. You do the same.
Glad that you're back, Professor. Have a good day.
Thanks. I appreciate it. Take care.